Hi, I'm Scott Prinos of the U.S. Geological Survey. Thank you for the opportunity to discuss the work of the USGS regarding evaluating the effects of rising sea levels on coastal freshwater resources and coastal ecosystems. This work is the effort of many USGS employees and contractors who collect and analyze the data. The names listed here are those who have developed analytical tools that can be used by water managers to evaluate short-term and long-term variations in our freshwater resources and coastal ecosystems. Next slide, please. Coastal water resource managers must address the following issues caused by sea level rise: increased vulnerability to flooding, including storm surge and king tides, reduced gravity drainage at coastal water control structures, saltwater intrusion in canals, streams, and aquifers, environmental impacts of increased salinity in coastal estuaries, and changes to groundwater levels resulting from differences in groundwater flow and drainage. Some of these issues can affect municipal freshwater availability, especially during droughts. Next slide, please. To assist water managers, the USGS monitors groundwater levels and salinity, monitors surface water levels, salinity, and flows, collects borehole geophysical information to evaluate saltwater intrusion, develops and maintains websites to provide up-to-date analyses of groundwater levels and surface water stage flows and salinity, maps the inland extent of saltwater and aquifers, seawater intrusion, maps the water levels in coastal aquifers, including changes through time, and develops computer models to evaluate saltwater intrusion. Next slide, please. One of the tools developed for water managers is the USGS Water Level and Salinity AnalysisMapper website. This website shows trends in groundwater chloride concentration and water levels. The graph on the left is a plot of chloride concentration of water samples collected from one of the wells that the USGS samples. Chloride is a key indicator of saltwater intrusion because salt consists of the ions sodium and chloride. You can see a clear-cut increase in chloride concentration through time in this graph. That indicates that the salt water is intruding at that location. The graph on the right shows groundwater levels in a well that the USGS has monitored for 65 years. Water levels have gradually increased since 1980. This website automatically evaluates trends like these and shows the results on a map. Next slide, please. This slide shows a zoomed-in example of the map, which summarizes the trend analyses of chloride concentration of wells sampled by the USGS. This is just a small section of the interactive map which is provided. Upward pointing arrows indicate chloride concentrations that are increasing through time. Downward pointing arrows indicate decreasing chloride concentrations. Circles and squares indicate that there was no statistically significant trend or that there was not enough data or analysis yet. An orange or red symbol indicates that the water is now undrinkable given EPA standards for drinking water. The red line shows the inland extent of saltwater intrusion in 2011. The green line shows its extent in 2018. You can see how far inland saltwater intruded in just 7 years at this location. Next slide, please. This slide shows another part of the interactive map, which now shows trends in the groundwater levels monitored by the USGS during the last 25 years. Upward pointing arrows indicate that the water levels have increased during the last 25 years. Downward pointing arrows indicate that the water levels have decreased during this period. Circles and squares indicate that there was no statistically significant trend or that there was not enough data for analysis yet. These symbols are color-coded based on how the current water level compares to historic norms. Green symbols indicate that the current water levels are normal. Blue symbols indicate that the water levels are currently higher than normal. Red or pink symbols indicate that the water levels are lower than normal. The user of this website can zoom in on any of the sites to better see where they're located. By selecting a site from the map, the user can see more detailed information and the graphs for each site. Next slide, please. Here is another USGS website designed to help water managers evaluate trends and levels. This website shows the coastal salinity index at surface water sites monitored by the USGS, the National Park Service, and the National Estuarine Research Reserves. Saltwater or surface water sites include those in streams, canals, or estuaries. The salinity index is another measure of how salty the water is. The white symbols that the water is saltier than normal, and blue colors indicate that the water is fresher than normal. The user of this website can zoom in on any of the sites to better see where they are located. By selecting a site from the map, the user can see more detailed information and graphs for the site. Next slide, please. This is one of the plots available through the website. This shows how salinity varied through time at the selected site. The red colors on this plot indicate that the water was saltier than normal in 2009 and in 2012 and 13. The dark blue colors on this plot indicate that the water was fresher than normal in 1999 through 2001, in 2005, and in 2017 and 18. Next slide, please. The USGS has also mapped groundwater levels in many of our nation's aquifers. Unlike the water level and salinity AnalysisMapper website, which evaluates long-term trends and current levels only at existing USGS monitoring sites, these maps consolidate data from the many organizations that collect it to create a snapshot of water levels in the aquifer. This is a more time-consuming process because the data must be obtained from many organizations that collect it. Often this water level information is in a variety of formats and must be adjusted and quality assured to be compatible. Once the water level at each site is determined, the black lines you see on the map are created to provide an overview of water levels in the area. These black lines are called contours. Snapshots of water levels are useful, but we generally want to understand what water levels are normal, high, or low for a given area. So the part of the map shown in this slide is one of a series of maps that indicate what is normal, high, and low groundwater levels for the period 2000 to 2009 in this aquifer. We compared these levels to a set of maps that were created for the period 1990 to 1999 to see how much these water levels have changed. Next slide, please. Improvements to the website currently being developed include adding surface water level, flow, and salinity data to the water level and salinity AnalysisMapper website, which currently only includes groundwater data. This is going to create a new website that's available. This will include improving the maps, graphs, and statistical analyses, evaluating changes at coastal water control structures, automatically bringing in data from other agencies to provide a more complete picture of water resources, and improvements to usability. Next slide, please. Here is an example of one of the improvements. This graph shows water levels at a surface water monitoring site operated by the South Florida Water Management District. The data for this graph are automatically pulled from this agency's database, processed just like the USGS data, and provided on a new mapper which is being developed. This provides a more complete analysis, a more complete understanding of trends and levels in water resources. This monitoring site is located on the tailwater side of a coastal water control structure. You can see the upward trend in water levels. Next slide, please. This graph shows an improved way of depicting changes in the chloride concentration of water samples through time. The black symbols are the results of analyses of individual water samples. The brown line is the result of a locally estimated scatter plot smoothing algorithm. The shaded background shows the chloride concentrations that are fresh, blue, and too salty to drink, yellow or red. Next slide, please. This is a schematic of a typical coastal water control structure. As sea level rises, the difference in water level across the structure is diminished, which can reduce flow through the structure. This can reduce the ability of water managers to provide drainage during extreme storms or hurricanes. For this reason, massive pumps are now being installed at some coastal water control structures. Next slide, please. This website, the website currently being developed, provides a graph that shows the long-term trend in the difference between the headwater and tailwater, that's upstream or downstream, sides of the coastal water control structure. You can see in this graph that the difference in water levels is diminishing through time as sea level rises. Next slide, please. Here's another way to look at the same data. In this graph, monthly mean differences are shown, and a 10-year trend line has been computed. This website is currently in review and will be released soon. We are looking at many other improvements that can be made to show how our water resources are changing through time. The goal of this work is to provide the best possible information to decision makers so that they can determine the best courses of action to utilize and protect our water resources and to protect the public from natural hazards. Thank you for your time, and I can answer any questions you may have.
All right, I see the first question coming in. Does the website contain information for the entire state?
Yes, it includes information for every station that the USGS monitors in the state of Florida, and also quite a few stations along the coast, along the Gulf Coast and the East Coast and in Puerto Rico. Okay, the next question is, what are some of the greatest challenges with saltwater intrusion? Well, one of the greatest concerns that water managers have is how the saltwater intrusion is going to affect our well fields. And by mapping the saltwater intrusion, we're able to, see how close it is to the well fields. And by looking at the differences in maps through time, we're able to see how quickly it's moving towards those well fields. And that allows water managers to begin to take actions to try to reduce the saltwater intrusion. Another question is, how much uncertainty is there in the speed of sea level rise for Florida's west coast? I would have to defer to NOAA for that because they monitor sea level rise. So the maps that were shown by the previous presenter, that's a website that NOAA produces showing sea level rise. Does the data allow for future projections? Yes, with some modeling, it's possible to create future projections. The USGS creates a variety of models and has developed advanced statistical methods for looking at data. What our goal has been in our center is really so far just to make that data readily available, to make it so that the water managers can see what's happening, to develop the computer models that other scientists can use to create projections and understand possibilities, including, for example, what would the effect of changes to our pumpages or changes to the way that we manage the canals affect saltwater intrusion. Another question is, are monitors, volunteers, or trained scientists? I volunteered once and the equipment needed to be upgraded. How upgraded our monitoring equipment? Well, the USGS operates quite a few standardized gauges. So we tend to stick with the same technology for a while and buy quite a bit of it in quantity so we can install it at many different sites. However, we have a vast variety of instrumentation in the field, some of which is brand new, some of which is older, all of which is quality assured to the highest levels. What are the best measurements, in your opinion, that can be taken to mitigate the issues caused by saltwater intrusion? I assume that's probably where the best measures, in your opinion, that could be taken to mitigate saltwater intrusion. Well, one of the things that we've seen in the maps is where water reuse has been extensively used. In that location, the saltwater front actually moved back towards the ocean because you weren't withdrawing as much water. So if you could increase your water reuse ability, reduce your withdrawals, then that can definitely help with that. Another question is there a difference? Okay, yeah, another question just popped in. Is there one central website to display all this information? The new website is going to consolidate the data from the coastal salinity mapper with the coastal salinity index with the water level and saltwater analysis mapper, and add additional information. Let's see. I might have lost my place a little bit. How would privately owned pools with chlorine affect your measurements? They wouldn't, because we're measuring chloride and we're measuring it deep in the aquifers. Do the adjustments caused by any problems homogeneity of station data? I think the best way to answer that question is that yes, when stations are operated to different quality assurance levels or operated using different methods, that can affect the data. That's one of the reasons why for years the USGS has really just evaluated much of its own data, and then when it brings in other data, it performs quality assurance measures to bring that data or to ensure that that data is up to snuff with the USGS data before completing the final analysis.